1 second. Okay, you can join now. Okay, use that. Okay, you can see that, right? Should be able to see that. Black. Hello? Or am I getting it back? Should be getting it back. Hello? No, I should not. Why am I getting it back? Maybe turn off your volumes. Hello? Yeah, that doesn't make sense. Yeah, that's fine. Should be okay now. What number did I write down? Oh, you guys, okay, you see it. Good. 5. Good. My messy 5. Said after 5. Okay, so we'll review a little bit of kinematics. So we've got four equations that we applied last year. Now we'll see how this works, right? I'm assuming that you guys are going to pay attention to this. Yes, recording it for you as well. If it doesn't work, I'll have to just switch to the projector or the TV. But let's see how you find it. So this is a review because obviously you've used these equations before. There's four main equations. Before I write them down, remember, this is key. People tend to forget. They're applicable only under certain constraints, certain conditions, constant acceleration or deceleration. And we can use them in the case of constant velocity. They simplify in the case of constant velocity. And we're going to do that. We're going to simplify some of these equations for constant velocity in a minute. But I want you to, from what you can recall, this is active recall, write down those four equations. And then We'll just write them down. I'll give them to you in a second. It doesn't matter the particular order. I'll give them to you in a second, but let's see what you can remember. And before we finish here, what do each of the variables mean and the corresponding unit? You could talk with each other. You can help each other. It's okay if you can't remember. I'll write them down in a minute. Let's see. Active recall. That's okay. I don't either. So end of lesson. Just watch my lessons from summer school all day. So, I'm just kidding. Okay, let's go through this in no particular order. Is a question, or you're going to try to give them to me?
I'll give them to you.
Okay, I'm going to be a little harder on you. I'm going to ask you what each of these are. What are the variables? What are the corresponding? We'll get to that. But thanks, Cam. This is not in any particular order, okay? So the first one, this is usually the first one you'll see written. VF is equal to VI plus AT. Now, some people, instead of VI, they'll use VO. V little, it's called a naught, V naught. Same thing. And the little arrow means vector. We'll deal more with what a vector is later. It's a vector. Again, in no particular order. So those are your four equations. Again, the little half arrows that I put on top means that they're vectors. They are going to have a direction as well as a number associated with it. Positive or negative direction. East or west. We'll come back to that in a second. Let's just go into more detail as far as the variables. So Cam, you tell me a little bit.
Okay. So VF for the first one.
Yeah.
It's the final velocity.
Okay.
VI is the initial velocity. A is the acceleration.
Okay, just one sec. Just take your time. I'm going to put initial first.
Makes sense?
Good. Yeah, that's your starting velocity.
Yeah.
And you mentioned, which one did you mention next? A?
A.
It's acceleration or deceleration. Usually we speak of it as acceleration. And leave space on the right for the units. We'll come back to that.
And T is time.
T is time. That's the scalar, right?
Yeah.
Only a number, no negative value for that. Anything else?
D is distance.
Yeah, it's related to distance. It's displacement, but you could think of it as distance with a direction. It's more than that, but to keep it simple for now, it's distance with a direction, as long as you don't turn around, it's the same value. Anything else? I think that's it, right?
That is everything.
Okay, let's write down the corresponding units. I'll do that for you. So yes, you can use, I'm going to use yellow. Meters per second. Yes, you could use kilometers per hour, but we have to convert always to meters per second. That's a standard unit that everyone uses. Acceleration is meters per second squared. Time is in seconds. Yes, you could talk about time in minutes or hours, but you'd have to convert to seconds. That's the standard unit. We want to always talk the same language. Everyone uses the standard unit. And then displacement is meters. Okay. Now we can talk about vectors. Vectors are quantities that have magnitude and direction. Magnitude and direction. Magnitude is just simply a number. It's just a number. Like if you're talking about speed or velocity, let's say we're referring to velocity, the number would be 5 meters per second. The direction we'd have to define either east, west, or positive, negative. So the direction, and we get a little more complicated later on as far as direction. We could talk about north, south as well, or even the angle that something moves at. But to keep it simple, we'll just deal with north, south, east, west to begin with. North, south, or east, west. Just to remind you what the actual directions are on a piece of paper. When we're referring to north, south, we're referring to it not as we see it in the real world, but on a piece of paper. Obviously, up is north, down is south. To the right is east, to the left is west. Alternate, okay. You can also talk about west as being negative. When we use actual numbers, you can either use, the best thing actually to do is, I find, insert your negative numbers for west and negative numbers for south. And alternatively, for east, it's positive. For north, it's positive. Okay. So yes, you've seen a lot of this before. Well, we've got to go through the review first until we can deal with, like I said earlier when I introduced the course, building on those concepts. You have to build on these concepts of kinematics. Okay, so I've got a little handout for you. We're going to go through these problems together. You've got the workbooks coming. So, yeah. Sure. Yeah. Now look at these.
Yes.
You prefer that?
Over
that
this.
projector?
I know, you can see it better than
It's
us.
right in front of you.
Okay.
Plus,
It
everybody
does
else.
look better.
That's good.
Feedback I keep getting. You guys,
Yeah.
you see it okay on the screen? Yeah, roll number 1 and 2 together. Looks okay?
Yeah.
Oh,
Mr. Pionia,
yeah.
I have a question for you.
Sure.
By any chance, you know when we get our conversion truck?
I'll take a look at when we take a little break here, I'll take a look at the emails I've gotten. Now I'm getting so many emails. Here's an email. I'll look at it later. Something on the buses, so I might refer to that. Okay, so read number 1 over. This is on page 24 of the handout. Number 1. Now how you do this is up to you. You can write on, I purposely gave you the handout so you can write on it. So the question obviously is already written out for you. You can rewrite it, provide yourself or give yourself a little more space to write on. Rewrite the question in your notes. You do it that way.
No, I can be up.
Okay. So just read it over. I'll go over. You probably remember a lot of this. Again, this should be pretty straightforward to begin with, but we'll have to go over it. Just keep in mind, anything that's west, we're going to add a negative to that. I would make a list. That's what we're going to do. Okay, so, gentlemen, just make a list. The list will tell you what equation to use. You can get your formula sheets now, get those out. I didn't see it earlier. They're on the back of your outline. This is what you're going to continually do until you actually get to know the equations. Make a list of the variables you're given and then choose the appropriate equation. In this case, the equation that contains all 4 is usually it's the first on the list.
Please excuse the interruption. Could Ina Marcelino please come to the front office?
Okay. Now, I suggest rather than plugging in first, and again, it's up to you, I suggest rearranging the equation to begin with. That way you get familiar with what it looks like. So at this point, you should be able to rearrange the equations, but I'm just subtracting VI from both sides to begin with. I subtracted VI from the right and from the left. I get that. I'm trying to solve for my acceleration. That's my unknown. Okay, so the next step then is to divide both sides by the time.
Mr. Keelan, I have a question.
Sure.
For number one, if we want to make it less positive, can we do that or not?
What you can do is just realize that you start with, obviously the velocities are both west, so your acceleration is going to be west. You can do that. So you just put in positive numbers. The point is that won't always work as we get more complicated. Some numbers are going to be negative, some are positive. So I'm just teaching you the consistent method, but if you can keep track of all that, that's fine. Yeah. Yeah. Yep. Did I not give you one? Yeah, just take one home. Okay, so we're going to round. Gentlemen, stop mumbling when I talk, please. We're going to round to 2 sig figs. Again, at this point, I'm assuming that you know are familiar with scientific notation. You should be from Physics 11. So 2 or 3, that's a general rule for us. Round the final answer off to 2 or 3 significant digits. Don't forget to put your negative in front. So this can be your answer, or you can simply just put 3.5 meters per second squared west. Same thing. I'll accept either. Okay. Number 2, do the same thing. Don't tell me. Write down the list. See what you can come up with. Notice what I did here. I rearranged the equation. I didn't plug the numbers in to begin with. It's up to you. I can obviously mark either. I suggest you do it this way. It's a little more hard, more difficult, but it'll pay off in the long run because you'll know what to expect and make less mistakes that way. That's what we tend to do in physics. Rearrange first, then plug in. We'll make a list first to number 2. Make a list of what you're given and what you're asked to solve for. And then choose the corresponding equation that contains, in this case here, all 4. This equation contains all 4. You can just straight plug in. You don't have to rearrange. If it's a positive number, you can just insert the number. And insert a positive at the end, or you can just put east. East is fine as well. You can put both if you want, or just one of them. But you do have to give a direction because displacement is distance with a direction. It's a vector. If you're going to put the direction in as east-west or north-south, make sure you include these brackets, these square brackets. Okay. Try number 3 out. That's weird. Oh, I copied from the old book. I see. Yeah, I see what you did.
What would be the difference between the final speed and the final velocity?
Speed is just the magnitude. It's going to be the same value, but velocity will have a direction to it. Oh, okay. I see what happened. Okay, so we got time still, guys, right? Am I off?
9:45.
You're right. I'm off. Okay, so for homework, just finish number 3 and Give number on page 29. Give number 1 a try. That's pretty easy, but give that a try.
So you have a good day.
Yeah, you too. I'll write it down for you here. So I'll finish number 3, page 24 and 4. Take care. And then on page 29, number 1. And I'll post this recording for you this afternoon. Have a good day. Take care, guys. Have a good day. See ya. Take care. You're welcome.